This is the second video about synthetic division. And if you're wondering, why do we even bother doing this? First of all, synthetic division is an easier way to divide. But the reason we use it is, think way back to when you had quadratics that you had to factor and solve. You know, and like this top one, you would factor it like this. Those answers are your x-intercepts, and this allows us to graph it. Okay, so we knew that we had to use the number, we had to multiply some numbers to get to 80 in order to find our answers for this. But when you have a problem like this, x to the fourth, and then all this polynomial, it still ends with an 80. We're still looking for numbers that would divide nicely into 80. So maybe the numbers are 8, 10, 1, 2, 4, 5, those kind of numbers, positive or negative. But we can't possibly factor that. So synthetic division helps us to divide this and find some of the first couple factors, and then eventually it'll come down to a simpler problem that we can divide. Okay, let's go back to dividing this problem. So this is a problem you saw a little bit ago. And if they ask you if x plus 1 is a factor, remember to do the synthetic division. We first change that to -1, and we write all the coefficients down into our divisor, or division box. And remember that these need to go in order, descending order, and if any one of them was missing, we'd have to put in a 0. All right, so we're going to multiply, and then add, multiply again, add, multiply again, add, just continue this process. And remember to draw a line. Now, that is our remainder. And since the remainder is 0, then this does work. Again, if they asked you if it was a factor, you would say yes. And if you say yes, and this works, then what's left here, you need to keep going and find the other factors. So -1 is a factor. You need to find the other answers. Now, bring this down. Remember, since we started out with x to the fourth and divided by x, this should be our x to the third, -5x squared, -16x plus 80. This should, at this point, once you divided the first time, it should factor from there. Now, whenever you have x to the third, and there's 4 terms, we typically factor by grouping. Okay, so remember here, I would take out an x squared. That would leave x minus 5. Then factor out a -16, and that would also leave x minus 5. Combine this together. Okay, and you can keep factoring, but you don't have to. If you recognize at this point that the answers would be both positive and -4 and positive 5, then that would suffice. You would be done. And these would be the 4 answers. Now, we're not doing it yet, but that's what's coming. Well, actually, we did some graphing the other day. But eventually with these synthetic division problems, once you've found all the factors, then you also are going to graph. So since this was an x to the fourth problem, and it was positive in the very beginning, remember that looks like a W. And based off of these 4 answers, if I just kind of do a rough sketch, pretend -1 was here, and then +4 and -4 were here, and +5. Okay, and these graphs aren't perfect. They just have the right look, shape, and go through the correct x-intercepts. That would ultimately be the entire thing I would expect from a problem like this. And eventually, they won't even give you the first factor. You would have to just guess and check and find out which ones work. And what we would do to get those guesses is you would think of all the numbers that are divisible by 80, which I know is a lot, but you usually concentrate on just the single digit numbers like 1, 2, 4, 5, those, okay? Maybe even 10, which turns out to be the answers that we got. All right, here's 2 more problems for you to see. And there's something a little different or unique about both of these. So, one thing, notice there's a term missing in the x cubed place. So when you set up these coefficients, you'll need to provide a 0 in between there. Okay, and remember, if it says x minus 4, the number that you're going to divide by is positive 4. And again, you should probably write down at least one of these with me, excuse me, so that you have them to look back at in your notes later. So, first thing, this is what some people forget. Drop that first number. Then multiply and add, and just keep continuing that process. Again, just keep multiplying. That's how I get this. Add those. Multiply, add. And I like to draw a line here at the end. That is your remainder. And then these go number, x squared like that. Or think, because this is x to the 5th, divided by x, then you're going to start with x to the 4th. So 2x to the 4th plus x cubed. Just continue descending in order. And then this is your remainder. So minus 8 over that, x minus 4. Okay, so if they had you to divide and give the resulting or the remaining polynomial, that's what you would do. If it asks you if it's a factor because there's a remainder, you would say no. Okay, now this one is weird because, you know, that's an easier factor because it comes out to be a whole number. So we divide it by 4. Here, if it helps you, think of 3x plus 2 equals 0, because that's really what you're doing up here. You're making that equal 0, which makes x be 4. If you did that, subtract 2 and divide by 3. So you're going to divide by negative 2/3, which is doable. It's just not as nice. So negative 2/3 in your little divisor box. And then these coefficients. Okay, drop the first number. Now, 3 times that, think about it, the 3's would just cancel and leave a negative 2. That's not too hard to do. This gives you 6. Okay, these down here will continue to be multiples of 3, so they actually will multiply pretty nicely with that. If you need to come off to the side and do negative 2/3 times 6 over 1, you could multiply straight across. That'd be negative 12 divided by 3, which is negative 4. Okay, or you could cancel the 6 and the 3, you know, and then multiply. All right, so then here we'd get negative 72. That's a little bit worse to multiply against this, but again, just set it up as 2 fractions. I would reduce on this. That would reduce to get a 24. And then multiply negative 2 times negative 24. It's 48. This is going to leave no remainder, so you just have this left, which is your x squared, your x, and your number. Okay, again, because we started with x cubed and divided by an x, so we're 1 degree smaller. So this is 3x squared plus 6x minus 72. That's what came from this. So based off of the fact that there's no remainder, you would say that yes, this is a factor. But because it works on all those problems, you'll see in the directions, I want you to go on and find the other factors. So finish factoring this. On this one, I would divide everything by 3 to begin with. That's a 24. And multiplies to get 24, subtracts to get 2, we know is 6 and 4. Okay, and then the opposite sign. So there's my other answers besides that. And again, since it's an x cubed, eventually I'll ask you to graph it. and it would be, you know, something like this type of a graph where here's your 4, maybe way over here is your -6, and then the -2/3 is right there. That's what it'll eventually look like. We'll do the next couple days once I get back. Good luck on homework.